A number x is chosen at random from the first 100 terms of the arithmetic sequence 2, 5, 8 dot 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 dot. Another number y is also chosen at random from the first 100 terms of the arithmetic sequence 3, 7, 11 dot 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 dot. Find the probability that x is equal to y. The terms Pm of the first arithmetic sequence are 2, 5, 8, 11 dot dot dot. Therefore, we can write Pm is equal to 3m minus 1, where m is equal to 1, 2, 3 up to 100. When we give different values to m, we get different terms for the arithmetic sequence. For example, when m is equal to 1, we get 3m minus 1 is equal to 2, which is the first term. If m is equal to 2, we get 3m minus 1, which is 6 minus 1, that is 5, which is the second term. Like this, it will go for 100 terms. Similarly, for the second sequence, we can write Qn is equal to 4n minus 1, where n is equal to 1, 2, 3, etc. up to 100. Here also, by giving different values to n, we generate different terms of the second sequence. Please verify that. When x is equal to y, for some value of m and n, we do not know what are those values. We have Pm is equal to Qn. Now Pm being 3m minus 1 and Qn being 4n minus 1, we get 3m minus 1 is equal to 4n minus 1, or 3m is equal to 4n. In other words, m is equal to 4 by 3n. Before going any further, please like, subscribe, share, and hit the bell so you can be immediately notified for new uploads. It's completely free and only takes a few seconds, and you can always unsubscribe later if you want to. Also, if you know about any interesting problem that you would like me to solve, please upload it in your comments. Without further ado, let's proceed with the rest of the video. We know that m and n are integers less than 100. Also, we know that 4n by 3 will be an integer only if n is a multiple of 3. Thus, n can be 3, 6, 9, 12, etc. up to 99. These values of n will result in the following values of m. When n is equal to 3, m is equal to 4n by 3, that is 4. When n is equal to 6, m is equal to 8. Like this it will go on. If n is equal to 75, m is equal to 100. And when n is equal to 99, m will be 132. But m has to be less than or equal to 100. Therefore, the last value of m would be 100, corresponding to n is equal to 75. Because if that is not so, m will become larger than 100. So, we conclude that there will be 25 values of n between 1 and 100, and those are 3, 6, 9, etc. up to 75. Similarly, there will be 25 values of m between 1 and 100, and those are 4, 8, 12, etc. up to 100. There are a total of 100 terms in the first sequence and 100 terms in the second sequence. Therefore, x can be chosen in 100 ways and y can be also chosen in 100 ways. Therefore, the total outcomes of x, y will be 100 multiplied by 100. Out of these outcomes, only in 25 cases, the values of x and y will be the same. Therefore, the probability of x is equal to y or p x is equal to y is equal to number of favorable outcomes divided by the total number of outcomes, which are equal to 25 divided by 100 multiplied by 100, that is 1 by 400 or 0.0025. This is the required probability. Thank you.